Hi, I'm Yang Kyung, PhD student in Edith Cowan University, Australia. In this video, we present our work that has been accepted to CVPR 2021, Unsupervised Learning for Robust Fitting, a reinforcement learning approach, a novel unsupervised learning framework that learns to directly solve robust model fitting. Here, we formulate robust fitting as consensus maximization. Given a set of measurements, the objective is to find the maximum number of inliers up to a predefined threshold epsilon. In addition to randomized and deterministic methods, some learning-based approaches have been proposed. However, most of them require large amount of label data, and the crowd tools is not guaranteed to be the gold standard. Inspired by the success of reinforcement learning, we proposed a novel unsupervised learning framework for robust estimation. Given a set of measurements X, we first solve the minimax fitting problem that minimizes the maximum residual. Then, we consider a set of points having the largest residuals. Here are three red points. At least one of them is a true outlier. So, our algorithm learns to decide which point to eliminate. The objective is to eliminate the minimum number of points until the residual is smaller or equal to the epsilon. Then, we encode a state with some crucial information, including first, all data points in the input set, second, the available actions, and finally, the traversal history before reaching the current state. An agent network will take a particular state as input and predict which point is the outlier. Here is the green point, such that the total reward is maximized. Since our state involves point sets, one expects our network to be permutation invariant with respect to the input. In order to do that, we design the first stage of our network to be a series of edge convolution layers, then obtain global features using max pooling. Finally, the global feature and the individual input features are then fed into multi-layer perceptron to obtain the expected accumulated rewards. The selected action is the action that maximizes the expected accumulated reward. The procedure is repeated until the agent reaches the goal state, where the largest residual goes smaller or equal to the epsilon. Our objective is to minimize the number of outliers, so we set the reward equals -1 after each step and 0 at the goal state. Our learning framework relies on a deep Q-learning approach. Interested readers can find more details in the paper. We first test the algorithms on robust 2D and 3D linear fitting with synthetic data with various outlier rates. The video example shows that the network learns to minimize the number of outliers after training. The upper figure compares the solutions found by our unsupervised learning method and a globally optimal algorithm. The heuristic in the optimal method brings the search into some subparts before discovering the optimal solution. We also test the algorithms on linearized fundamental matrix estimation and homomorphy with semi-synthetic and real dataset. The runtime of the optimal method increases exponentially with higher outlier rates. In particular, over 20% outlier, the optimal method is too slow to achieve the solution. We generally obtain higher consensus sets compared to transact-based method and the state-of-the-art unsupervised learning method. We show some example visualization with Kitty dataset and Roman Forum dataset, which show that our framework can work with images taken from distinct cameras from a large variety of positions. Thank you. Please check out full paper for more results and detail.